Hi, my name is Clark Snell. I'm the managing director of the Nauhaus Institute, which is a nonprofit dedicated to finding carbon neutral solutions for the built environment. What's the point of that? Basically, climate change. We are warming up the planet. That's the initial impetus, is going to be warmth, and then other things are going to happen. It is our fault, and it's our fault because humans' fault, because we are burning too many fossil fuels that put carbon into the atmosphere. It's pretty much that simple. So the solution is also very simple. We just need to stop burning fuels. The way we do that is becoming more efficient. So I'm standing in front of the Nauhaus Institute's prototype carbon neutral building. One of the main components of this building is hempcrete. I'm standing in front of a hempcrete wall. What hempcrete is industrial hemp. The core of the stalk of an industrial hemp plant is called shiv. It's a woody fiber, and it's mixed with a lime-based binder to make an insulation material that you can build walls or roofs with. The reason that we're using it, and I think it's interesting in terms of the whole hemp debate, I think this is the best wall system in the world. So I'm all about hemp. I think hemp's an important thing to push because it's food, fiber, building material. But really, I'm choosing this material because it's the best in terms of building science. And why is that true? First of all, because this is what's often called a breathable wall system. And I don't mean breathable for air. We're actually building an airtight wall, but it's breathable for water. And why is that an advantage? Well, in a typical wall, you have a cavity that you seal tightly and then you fill with insulation. Well, water will get inside that cavity because water that's its job in the world. My body is 70% water. The surface of the planet, I think, is 70% water. It gets everywhere. It can climb uphill. It's through capillary action. It can dissolve any material. Anyway, so what we want to do in a building is create a wall that welcomes water but doesn't rot when it lets the water in, and that's exactly what hempcrete does. When humidity changes in the air outside, the wall can take on that extra humidity and hold it until the humidity drops outside, and then it will let it back out. In the meantime, because the lime is wrapped around the cellulose won't rot. So therefore, we have a wall that can adjust naturally to humidity levels without rotting. That means that this wall will last a very long time. It also means that indoor air quality is going to be much improved. Now we're on the inside of the building. We were talking about the breathable qualities of hempcrete. This is a hempcrete wall with a scratch coat of earth plaster. This is actually a plaster that we made on site with just clay, subsoil, and sand we mixed together. This is another great quality of a hempcrete wall, that we're able to plaster directly onto it without plywoods, drywalls, laths, drainage planes. It's simply the material itself, the insulation itself can be plastered. That saves us a lot of steps, a lot of time and money, and also it allows us to create this breathable wall I was talking about. So now we have the hempcrete interior, which is permeable to water vapor, as I was saying, and then we plaster it with either a lime or an earth plaster, which is also permeable. So then the surface, which is going to be, in the interior, of course, it's your protection against crayons and whatever else is happening inside, and the outside is protection against liquid water. Those things have the same permeability to water vapor as the hempcrete itself. So therefore, we're in the inside of the building. Let's say you're in a shower, or let's say that this is the kitchen, and there's water vapor in the air. The wall will take that on and hold it until the interior relative humidity goes down, and then it'll let it back out. So we basically are creating a stable interior relative humidity with a passive material, just with a wall material. So that's a huge advantage of hempcrete. It's basically, in the simplest way of saying it, it's a healthier wall. So we said it's a longer lasting wall because it deals with water well. It's also a healthier wall because it deals with water well. Another advantage of hempcrete is that it's carbon sequestering. You remember before I said that our goal is to be carbon neutral. Well, hempcrete actually sequesters carbon. Let me tell you how it does that. First of all, any cellulose material, wood for example, or hemp, takes carbon in during its life cycle, and usually when it decays, it lets it back into the atmosphere. If you take that plant and then put it into a wall, for example in hempcrete, then that carbon is now sequestered in the wall and not becoming part of climate change. So the hempcrete in this building, this one building alone, will sequester 20,000 pounds of carbon. That's a pretty big accomplishment, and it's all thanks to hempcrete. Hempcrete is part of the natural building world. What are natural materials? They're basically materials that are usually local or site harvested or have low embodied energy like hempcrete does. They're also materials that work well with the site. And one thing that's great about hempcrete is that you can create a strong wall of different thicknesses based on what your insulation needs are. That's because you use forms around some kind of other structure like wood that will hold up the roof, and then you form around that and put the hempcrete in the cavity. So for example, in our house here, the Nauhaus prototype, since we're trying to get to such high energy efficiency levels, we have a 16-inch thick wall to get us a performance rating of R40. We could also do a 10-inch wall. So we have flexibility in terms of the amount of insulation that we're going to use with the exact same procedure for construction. That's fairly unique in the world, and it's another reason why hempcrete's a really great product